All right, guys, welcome to this video here and working out of my Mad Engineers lab today. So today we're going to talk about layout techniques. So what are some different layout techniques? Well, first off, layout here is nothing more than applied geometry. And okay, now as soon as you hear that G word, everybody starts freaking out about it. But really all we're doing is instead of using numbers and stuff to solve equations, we're just using pictures and really straight lines and circles. Everything in geometry basically breaks down into properties between straight lines and circles. The masters of geometry were really the Greeks and Romans. And well, the reason they got so good at it is because their numbering system sucks. And I'll give you an example of that. So, Roman numerals, we got 1, 2, 3, nothing too crazy there. Sorry, my whiteboard's a little wet yet. Then we get into 4, and 5, and 6, and those are the ones we know. But now let's start. I see that's a little thin. Just give me a second here. But now we see that. Now let's try doing a little math with that. So, okay, if I go 2 plus, so now I can get 2 plus 3 equals V. Well, that gets a little confusing. Well, let's see what happens if we do some of these other ones. So, let's go, hopefully that's dry enough. Let's go V times X. Yeah, okay. Now we're starting to get even more complicated. Now let's go X times O times L plus and heck, we're just even doing straight multiplication. Now we're going to come out with something like, okay, so x times 3 times L. So 30 times 50 is 150 plus 8, which come out to be CLVIII. Yeah, you can see where that gets really fun. So, let me grab my rag here to wipe this down. So as you can see, doing any sort of advanced mathematics with Roman numerals isn't all that fun. But these are the people who were able to build the Colosseum, the Parthenon, places that and have aqueducts that ran literally hundreds of miles with a perfect 1/10 of a degree decline, and still function. Some of them are still functioning to this day. So obviously they came up with a way around that, and how they did that was by using straight lines and circles. Now we're going to get into more in the second video here. I'm actually, instead of trying to draw that stuff up here with a straight edge and that, and a compass, because that's really hard to see here, I'm going to be standing in the way most of the time. What I'm going to do is cut another video, and I'll have that posted up later today, with a, where I did it on the CAD program. And you'll be able to watch and, you know, how everything intersects, and it'll go from there. So, anyways, terms that we need to, the things that you're going to need to do the homework for this. Very first thing you're going to need is a straight edge. And your rulers will probably be good enough. Now, the longer your straight edge, the easier it is to get kind of bendy and wavy, so you might want to be a little careful with that. But it's probably going to need something more than just that 6-inch machinist ruler. A 12-inch ruler, piece of straight steel, any of that's going to be straight enough for these purposes. Again, we're not doing precision machining. I don't care if you got a parallel that's flat to the 10,000th or anything like that. Other thing you're going to need is a geometry compass. You can pick these up for less than $1 anywhere. Amazon right now, Walmart, any place like that will have it. Compass lets you draw circles. Straight edge lets you draw lines, and we're going to talk about how to do how to work with some of that. Now, if we got to draw straight lines over a longer distance, so most of the time your ruler's going to be 6 inch. You might have a straight edge that's 2 or 3 foot long, but say we need to go even longer than that. One of the biggest tools you're going to use there is a snap line. Snap line is basically a piece of string coated in chalk. We're going to pull it tight, snap it, and it's going to leave a line of chalk right there. Now, snap lines are great, especially when you have to go very, very long distances. And most of these come in different colors. When I was doing layout in the construction industry, or I actually helped doing installations and that stuff, we'd get our prints in and we'd find out where everything was supposed to run, from our safety fences, conveyors, where we wanted the electrical, hydraulics, airlines, things like that. And we'd stretch them out, each one being a different color, snap it down, spray paint it with clear lacquer so it didn't get wiped out, and go from there. Worked really well. Now, some things we're gonna run into when we're laying out. First off, you have to work off of a known point, and we're gonna see some of that in your homework. We're gonna see some of that like when you're doing your layouts for your cutting test in Oxy. What happens there is we need to know exactly where we're working off of. Our tolerances on stuff are only going to be given off of applied dimensions. And when we're doing small parts like what you're going to do for Oxy, they're not going to be too far off. When you start dealing with bigger and bigger things like buildings and stuff, you'd be surprised how much tolerance is allowed inside there. I personally have ran into issues where we started measuring off of a door as it came through, a concrete cutout, and for one set of stuff, and then a building pillar for the other set of measurements. And well, on the print, everything worked out perfect. The real world, not so much. That pillar was off, we figured, about 3 inches from where it was on the drawing. Close enough for structural work, not close enough for layout work. So one of the things when you get out in the real world, double check that everything is exactly where it's supposed to be, because remember, we got our tolerances we got to take into consideration. And our tolerance is the difference between acceptable and perfect, and sometimes if we're dealing with really big projects, that tolerance can be quite big. So make sure you're taking that into account. Other things that we can do with this is we can find guys to lay down beads. Everybody can find someone to go and pull a trigger somewhere, but if you can't get the weld where it has to be according to the print, you're not going to be you're going to be basically on the bottom end of the food chain for your entire career. We have lots of people who can pull a trigger, and the number of people who can read a print and take that print and transfer it onto a workpiece, which is the techniques we're going to be talking about, this are getting fewer and fewer. And when you start getting into bigger and bigger projects, being able to get those pieces or markings transferred over accurately, first time, every time, and within tolerance is incredibly important. We have jobs here in town that if that's all you need to do is be able to run a tape real well and read prints well, and you're going to make more money than the guys just sitting there pulling triggers. So some things we want to watch with this. We've talked a little bit about this already, and I want to go over this again because, well, it's been a while since we talked about it. Some symbols we're going to see. Whenever we're dealing with, trying to dry this off. I didn't realize it was quite that wet, so I don't want to do another cut. Anyways, so first symbol, there we go. Nice big R. Say I got an R of 0.5. What the heck does that mean? Well, R is what? Radius. Remember, we're going to be talking, I told you that everything that we're going to be doing is just straight lines and parts of a circle. So what is a radius? Well, radius is the distance from the center of the circle to the edge. And so a 0.5, so we're saying that's 0.5. So the other symbol we're going to see looks like that. Circle the line through it. This is your diameter. Diameter is simply 2 radiuses, or the distance completely across the circle through the center. If you have a distance across the circle that's not through the center, that's called a chord. We will deal with that later. We'll talk a little bit about that in Blueprint. We'll talk a little bit about that in Applied Math, but that's a little bit more advanced than we need to get into for right now. So, make sure you keep that in mind. Now, when you're setting your compasses, you're going to be setting it as a radius. And if you forget that and you set your compass as a diameter, your parts are going to be off and your prints are going to be off. So on the homework that I opened up for you guys, what I want you guys to do is to be able to take those prints. I need you to draw them out, but they need to be as exact and as close to measurements as we can possibly get. I'm only giving you guys a plus or minus a 16th. And so then what I need you guys to do, and this is where it's going to get a little tricky. I either needed you to scan them in full size for me if you got access to a scanner, or if you guys do not have access to a scanner, when you go to upload them, take a picture of them, but I want you to have your 6-inch machinist rule on the print or on the piece that you're drawing out so I can see it. Now the pieces that are coming to you, you have to actually give the measurements because they're in a really, really oddball scale, and I did that intentionally. So you can't just trace them, or you couldn't just go and scan them and maybe try blowing them up. You could do that, but it's going to show up really quick when you, because I know exactly what that's going to look like. So that's where I'm going to stop right here. Now so part 2, we'll see if the voiceover in that works, but I'm going to show you how to use circles and straight lines to make many different complex shapes. So we'll stop here and go to the next one.